Okay, so welcome back. Reminder that according to the Gantt chart, you should be almost finished with designing your test cases. Remember that a test case is a input-output pair. In the second exercise in that first assignment, you actually have to codify that using JUnit, which we give you some examples for. But otherwise, for the first one, it could just be a piece of paper, on a whiteboard, a calculator, whatever, right? It's simple enough that you can do that. The third one, however, we do give you another one of our test cases. You can go ahead and play around with that and make it smaller and make up your own test case for the third one. But otherwise, what you should be doing after that is, by tomorrow, you should start with a rough draft of your programs for that first assignment. Certainly by now you should be able to get the first assignment, and by the end of the day you should we've covered everything for the first exercise and the second exercise by the end of the day. The third exercise is a bit more involved because it requires data processing, file I/O, and potentially classes. But certainly by the end of the week we'll have gotten to the point where you can probably be loading up data from a CSV file. But otherwise, that's where you should be for the rest of the week, okay? I do want to take a step back. Last time we left off with talking about lists and how they're so much better than arrays. We were about to talk about sets, but before they do that, remember that you generally only use arrays when you have to. And one of those situations where you have to is when you've got 2D arrays. 2D arrays are two-dimensional arrays. Sometimes we call these matrices. Right, if you're mathematically inclined. Otherwise, if you've got rows and you've got columns, what do we call that thing? A table, right? So I want to create, let's go ahead and create an integer matrix or table of size 3 by 5, right? So in other words, 3 rows and 5 columns in each row, right? I'm going to create an integer array. Now, I'm not going to use ARR because it's not an array. Instead, it's a matrix, so I'll call it MAT, short for matrix, and it has 2 dimensions. Whereas an integer array would have 1 dimension, here we're going to have 2 dimensions, the number of rows and the number of columns. I still invoke it using that new keyword. I want a new integer matrix or table, whatever you want to call it, 2D array, and I want it of size 3 by 5. That's it. That's all you need to do to create an integer array. Then you can iterate over it and play around with it all you want. For that, you're going to need 2 for loops, for loop and for loop. Why? Because for each row, right, and then for each column, there we go. So I'm going to iterate over each row and then for each column. Well, for each row, it's just an idiomatic for loop, that one of those regular for loops that we've already covered. Int I equals 0, I is less than the size, the number, so 3, right? That's because that's the number of rows. We'll come back here and fix that because I don't want to hard code that. I plus plus, okay? Now, can I use I here for my second loop? No, because I've already used it for my outer for loop. So for int j, because j comes next, I, j, and then k if we had 3 nested loops. J is equal to 0, j is less than 5, and again we'll fix that. I don't like hard coding that. J plus plus. And then you can set matrix of I, j equal to whatever you want. Say I times j plus 10. That's good. It's just some number. It doesn't really matter. I want to fix this right here. I don't want to hard code this to 3 because I don't want to keep track of 3. Remember that Java builds in the size of an array of the language using the length property. Those coming from a Python background will remember length, len, right? You can give it a collection and get the length of that. Those coming from a C background, remember that you have to put this into a variable and do all the bookkeeping yourself. Instead, what I'm going to do is I'm going to say mat.length, right? That gives me the number of rows. Now, what about the number of columns? If I did mat.length, that's 3. That's not 5, right? What I want is the number of elements in the ith row, right? So tell me how many there are in the ith row, dot length, right? This one gives you the number of rows. This one gives you the number of columns in the ith row. Since they're all the same, since the first row is going to have 5 elements, the second row is going to have 5 elements everywhere, you could just say sub 0, right? But There are instances where you can create a 2D array where the first one has 5, and the second one has 4, and the third one has 2, and the fourth one has 50, right? You can have different dimensions. Why would you do something like that, though? That's weird, right? You could probably come up with a better data structure, a better way of doing something like that. But this is a little bit less fragile, I should say, right? Less brittle, okay? Let me go ahead and run this, and it's not satisfying because there's no output here. So let's go ahead and iterate over everything again and print them all out, right? So for each row, for each column in that row, I want to now print the results of that. System.out.println, right? I can say matrix of ij. Right? I don't want to set it, I want to print it. That's also not satisfying because, of course, it's giving me all these weird numbers, all right? So what I want to do is I want to print it in a nicely formatted manner. I want 5 elements in the first row. Then the next row is going to have 5 elements. Then the next row is going to have 5 elements. And I want like opening and closing square brackets to make it look nice and pretty. So let's go ahead and do that. For each row, I'm going to start out with system.out.print, not ln, because I don't want to go to the next line right now. What I want to do is I want to print an opening square bracket. Likewise, at the end of each row, I want to print a closing square bracket. Okay? Now, for each one of these, I'm not going to print a line. Instead, I'll print this along with, I don't know, maybe a comma. There we go. And let's see what that gets me. Right? So it's looking better here. There's the first row. There's the second row. What should I have done here at the end of that, though? Here, at the end of that row, I'll go ahead and go to the next line. You could, of course, trade that out for a print ln, but I'll just go ahead and go with an explicit unline character there. Still not all that satisfying because I've got all those trailing commas. How would I get rid of those? An if statement, right? I could put an if statement in there that says if this is the last one, then don't print this thing, right? Or what I could do is I could stop short by 1, right? Print all, comma for everything except for the last one, and then print out the last one by itself. ij. Uh-oh. Do I have access to j anymore outside of this loop? Nope. It was scoped only to that loop. I just want the last element, right? So what would the index of the last element be? 4. Yeah, for this particular example. But how do I get that 4? Yeah, matrix of length -1. Why -1? The length is what? 5. There are 5 elements in that row. 0, 1, 2, 3, 4. So we need to subtract 1. Right? Yay. Here's an even better way of doing it, much easier. Right? So for each row, if you can get away with using a library function to do something for you, you do it. Right? System.out.println. Let's just go ahead and print out the ith row of that matrix. This is not going to work, right? Because we're going to get all this weird stuff here. Does anybody recognize these things? What do they kind of look like? Addresses, memory addresses. It's printing out the memory address of that array stored in memory. Right? I don't like that. I want the actual contents. So I'm going to have to ask arrays.toString, convert that thing over to, arrays.toString matrix, there we go, and there we go. I don't know why it jumped to the top there, but I need to import that, and that's a nice way of formatting it in a human readable format. There we go. So anytime you have an opportunity to use something that's built into the language or that there's a standard library for it, you do it. Which one of these is better? Lines 23 through 30, rolling my own, or lines 32 through 34. Right? It's shorter, it's less brittle, and it was quicker to write. Right? All I had to do was write this one. Okay? But otherwise, there are 2D arrays. You're going to need that for your second exercise in your first assignment there. I'm going to go ahead and put that into the notes, but I'm going to put it under arrays where it should have originally been. There. All right, so that's in the notes now. Okay. Let's go back to sets, because as we said, you only use arrays when you absolutely have to, like 2D arrays. Otherwise, you use lists. A set is different than a list in that it is unordered. There is no first element. There is no last element. There is no ith element, right? There is no first, last, or ith element. Right? It's unordered. It's like sometimes people call these things a bag, because if you've got a bag of stuff and you just put it into the bag, do you have any ordering in the bag? If I dump the bag out on the table, is it going to come out in like any sane ordering? No. Also, it's unique elements. If I try to put multiple things in there, like two fives, it's not going to work, right? There's only going to be 1 5 in that collection. Let me show you. So here's a set. Let's go ahead and go with strings for variety here. I'm going to call it names is equal to new hash set. It's a hash-based set. We'll talk about hashing maybe later on. But otherwise, you have to import these two things, import and import. Again, all of these things are going to be part of the java.util package. Util short for utilities, right? Utility functions, utility classes, all that stuff. Names.add, my name. There we go. Names.add, let me go ahead and add 10 here. Am I going to be able to do that? No, because this is a set of what? Strings. So I can't add 10, but I can add Kyle. Right? Names.add, I don't know, Grace Hopper. Names.add, Craig. There we go. All right. Now let's go ahead and print that out. System.out.println names. Println. Right. Okay. Now, is it going to be Chris, Kyle, Grace, Craig? It's unordered, right? So Kyle, Grace, Craig, Chris, right? It's not the order that I put things in. It's just a bag of stuff. The order that it actually gets printed out in, you don't even really have, it's meaningless. Don't worry about it, right? You can always add stuff, but again, it's unique elements. So if I try to add Craig there twice, probably should add Kyle twice instead, but let's go ahead and run it again. Are there 2 Craigs in there? Nope, because it is a set, unique elements. Adding duplicates has no effect on it. But otherwise, you can do things like int size is equal to names.size. Right? How many things are in there right now? That should be 4. Oops, size. Right? Because there are 4 things in there. You can remove things. Names.remove. Right? I can remove Grace from there. Actually, let's remove me. There we go. And you'll see that now my name has been removed from that set. Right? Oh, I'm gone. And then the size has been updated to 3. This size variable has not been updated, but if I called size, it would now be 3. Okay? All right. That's a way to put stuff in. It's a way to remove stuff. Remember CRUD, create, retrieve, update, and destroy. We have a way to create stuff. We have a way of destroying stuff. Updating is just the other, or 2 of the other things. So how about retrieving things? I want the first guy's name, right? Or in this case, Grace's name, or I guess Kyle now, right? And I'll just say string foo is equal to names.get. I want to get that first element. It doesn't compile. Is there such thing as a first element? No, it's unordered. So how do I go about retrieving things? Right? This is where the enhanced for loop comes in. For string name in the collection names, system.out.println name. And it'll probably be the same order as when it gets printed, Kyle, Grace, and Craig. But again, it's unordered. Okay. If I added myself back in, I don't know if I would be the last anymore, right? Let's go ahead and add me back in there. And no, I'm still the last. Okay, for some reason. Just because that's how the hash table works under the hood. Okay? But otherwise, you are forced to use that enhanced for loop, right? Because there's no other way to do it. If I used an index-based loop, int I is equal to 0, I is less than n, I plus plus, there is no ith element. I wouldn't be able to do that. Okay? So it seems like sets are a little bit more restricted. But you can use them to do a lot of powerful stuff. For example, if you want all the unique elements in a collection, you've got a list and you've got a bunch of duplicates, dump it to a set. And now it's eliminated all the duplicates. Dump it, you want to sort it now? Dump it back to a list, and we'll talk about sorting later. You can always change a list into a set and a set into a list as follows. Let's go ahead and change a set into a list. Right? So a list of, let's say, strings, because that's what I'm working with right now. And I'll call it foo. I've already used foo. Have I used foo? No, I haven't used foo. All right, foo is equal to new array list of strings. But instead of providing empty parentheses here, what I'm going to do is I'm going to pass in that set collection right there. That converts this set into another list. Now I've got two copies. I've got a set version of it, and I've got a list version of it. Let me show you. Let's just print it out. Names is still the same, and then foo is now an actual list. Right? It ends up being the same thing, but that's just because we're not adding anything to it. Let me go ahead and show you how if we did add something to it. Let's go ahead and add names. Is Joe in there? Nope, there we go, Joe. Okay. Let's run that again. And you see that Joe has been added to the set, but Joe is not part of my list because now they're two independent things. We call that a deep copy, right? We'll talk about deep copies in maybe more detail later on, but those coming from a C background, remember that a deep copy is you've got a reference to one copy and another copy, exact same contents here, but there are different things in memory. So if you change this one over here, it does not change this one over here. The shallow copy would be the exact opposite. You have two references, but they reference the same thing. So if you change one, it's changed for the other. This is how you deep copy collections in Java. Right? So this is a deep copy. Right? Let's do the opposite. Let's go ahead and change that list back into a set. Set string, I'll call it bar, is equal to new hash set of, and I'll pass in foo there. Right? All I've done is taken that foo, which is a list, and I've passed it into a hash set, which gives me a set copy of all of those names in that foo. Okay, so this is converting a set, or sorry, a list to a set. You can always go back and forth if you need to. Right? All right. So that's sets. Once you are familiar with the next thing, though, you're not going to want to use either one of those anymore. You're always going to want to use maps because they are the best, right? So a map is kind of like a dictionary, in Python, right? It is a key-value pair mapping, right? It maps keys to values, right? Keys are unique, right? In that you cannot have a key map to more than one thing, right? Values can be duplicates, right? You can have different keys mapping to the same value, right? You know these things as functions. What is a function? X-axis, Y-axis. What are you mapping? You're mapping an X value to a Y value, right? For example, if we've got the function, let me write it out. Let me go into math mode here. F of x is equal to x squared, right? Now let me go ahead and give you an example, right? What if it was 2? What if I said f of 2? What is the value then? It now becomes 4, right? What if it was negative 2? The value is also 4, right? In other words, two different keys, two different values on the x-axis can map to the same values up here on the y-axis. What about the opposite direction? Can I have values, can I have, say, two values map, or one value, one x value maps to two y values? Can you do that in math? What if you were able to do that? You'd be able to draw a circle because one x value can map to positive 1 And one x value can map to -1. Is that a function? Is a circle a function? Why? Fails what is that thing called again? The vertical line test, right? In other words, maps are nothing more than what you're used to functions, okay? So just understand this is nothing new. However, they are powerful, and in fact better than dictionaries, in that you can map anything, any type, to any type, right? Okay? Now, technically in Python, a key only has to be hashable, and that's the same in Java. But everything built in is already what's called hashable, but don't worry about that detail, okay? Let me go ahead and create a map here. A map that's going to map, I don't know, an NUID, which is what we're going to treat as a string, to maybe a name, right? So this is going to be a NUID to, actually no, let's change that to an integer, because NUID to name, right, is equal to new hash map, right? And I need to import these things. These are all also in the java.utils package, right? So it's getting cluttered up here, by the way. If I were to turn this in, it would probably maybe lose some design points here, because I am importing stuff that is not being used, and I'm being warned about it, but I'm not paying attention to the warning, right? So I'm going to go ahead and delete everything that I'm not using, right? There. Don't import stuff if you're not going to use it. You might also see some example code out there that does something like this. Import java.util.star. That imports absolutely everything, right? That is terrible practice. Don't do that, right? That means that you end up importing every single class, hundreds and hundreds of classes in that package, right? Only import that which you are actually going to use. Be more intentional about your code. Right? Otherwise, the actual syntax here now. Same langle wrangle but as before, but now I've got two things. I've got a key, comma, value, right? And the key in this case is going to be an integer type, and the value in this case is going to be a string. Let me put something into that map. NUID to map to name dot put. Let me put my NUID 35140602 and to my name. There we go. I'm not adding it. Add is something for lists and sets. I have to put something into the map because I need two things. I need the key mapping to that value. Right? Let's put another one in there. 1, 2, 3, 4, 5, 6, 7, 8. And we'll put that as Grace. And then one more maybe. 8, 7, 6, 5, 4, 3, 2, 1. And we'll go with Alan there, Alan Turing. Okay. So now I've got a map. System.out.println NUID to name. And when I print this out, you'll see that the mapping is preserved. That number maps to that string. That number maps to that string, and that number maps to that string. Right? How do I retrieve stuff? Because remember, CRUD, create, retrieve, update, and destroy. That's how you create things. That's how you can put stuff in. Oh, actually, before we retrieve, let's take a look at what happens if you overwrite something. NUID to name dot put 8765432 We'll go ahead and put in there Joe. Right? There we go. Is Alan preserved? What happened to Alan there? His key got overwritten, and Alan is now gone, and Joe has taken his place. One key to one value. You can have multiple keys going to the same value. I could have, say, that, let's go with 0 there instead. And then we'll go with Schmo. There we go. And there. Actually, no, I want Joe to demonstrate that we can have multiple duplicate copies of the same value here with the different keys mapping to the same value. That's what I wanted to demonstrate. Okay. How do we retrieve somebody? I want me, right? I want, me. There we go. I want NUID to name. Now it is get. It does make sense here. What you need, though, is the key. Right? And the key in this case is going to be my NUID, 35140602. Right? And then I can print myself out. Println me. Right? There I am. All I need to do is turn the key and it opens the lock and gives you whatever it's mapping to. Okay? What happens if we retrieve something that does not exist? U, right? And 99999999. Is that key part of the map? Nope. So what do you think you are going to be when I try to retrieve you as 999999? Null, right? It's saying it does not exist. Those coming from a Java background are going to immediately recognize, or sorry, from a C background are immediately going to recognize this, right? If U is equal to null, or sorry, right? This would be in C, all caps, but it's the same idea, right? System.out.println not able to find you. There we go. Right? And it'll print out not able to find you. Right? That's what null is. It's non-existent. Those coming from a Python background recognize this. It's the same concept. What do you use in Python though? Not null. It's another word begins with N. None. Right? None. There we go. All right. None. All right. All right, so that's create, retrieve. How can we iterate over values? Right? And you can remove them. You just have to reset it. What would it be? NUID to name dot remove. Remove. Let's remove that second Joe there, right? And you'll see that this is not. I want to print that out. Now that second Joe has been removed. Okay. All you have to do, but you have to remove them by the key. You can't go through and find the value because then you'd have to go back to the key. Can you invert a function? Sometimes, right? But what do we mean by inverting a function? Let's go back to our math class here, right? And let's go ahead and go with f of x is equal to x squared. There. Right? What's the inverse of that function? Can you invert it? The inverse of the function is going to be like mapping it back. Given an x value, or given a y value, map it back to the x value that gave you that y value. Can you? What would be the inverted function there? F of, we usually call it -1, right? Inverse of x. Come on. There we go. All right, F. I have to write it correctly. There we go. Is going to be equal to what? Square root of x. Like that. There we go. Square root of x. But is it? It would be plus minus square root of x, right? Technically. Is that a function? Can you map one value to two things? Careful. That fails the vertical line test again. You'd have to choose one side or the other. In other words, no, you can't invert every single function. Okay? That would actually be two functions that you'd have to take a union of or something. So can you invert a map? Yeah, but what happens when you've got this two Joes there, right? How do you invert? Which key do you map that back to? Right? There are two values there. You have to choose one. But let's iterate over values. You can iterate you can iterate over key value, the values in the list by doing the following. For the values in this case are what again? Strings, string, name, in, name to NUID, or NUID to names. Sorry, not in. There we go. Thinking Python there because I do Python in the other section. NUID dot values. Dot values gives you a collection of all of the values. In other words, it takes away the map and it only looks at the values that are being mapped to. And this is going to give us all the names. System.out.println name. Right? And I'm iterating over each one of those names. Chris, Grace, and Joe are the only ones left. Or you can iterate over the keys. And this is probably the better way of doing it because it gives you the best of both worlds. So for the keys in this case are integers. So for each integer, NUID in NUID to names. And here you go key set instead of values. Right? That gives you a collection of all the keys in that, that collection. System.out.println NUID. Right? There are all the NUIDs. And I say that this is the best of both worlds because once you've got the key, you can always get the value, just like we did above. String name is equal to NUID to name dot get NUID. And now I've got both of them. Maps to, and then concatenate name. So there's my NUID that maps to me. There's that NUID that maps to Grace, etc. Right? This is probably the better way of doing it because, well, if you need the values, all you have to do is iterate over the keys and get each one of those values. I would only ever do this if I absolutely do not care about the keys at all. Right? Now, why is this so cool? Right? You can solve a lot of problems here really, really quickly and easily. Right? I always go back to, let me see. I think I did it yesterday up at Omaha. Let me grab, oh no, I didn't, okay, it's gone. Let me go ahead and create a list of, say, strings that represent zip codes. New array list. Right. There we go. And I shouldn't have deleted all those imports because I do need them right now. And I like this exercise because I think that they do it in 155A. That given a whole bunch of zip codes, what I want to do is I want to have a count. Right? So zip codes dot add 68116. There we go. And what I'm going to do is I'm going to add them 4 times. Actually, let's go 5 times. And then let's add another zip code here that's different. Right? 68503. Right? We'll add that 1, 2, 3, 4 times. So I've got one zip code that appears 5 times and one zip code that appears 4 times. This is also how you design test cases. You manipulate the test cases so you know the answer without having to actually do it, right? I added this in 4 times, so I would expect that, that the report would output 4 for 68503. And let's add a few others, just ones that appear once. 90210 and 1, 2, 3, 4, 5. There we go. All right. So system.out.println zip codes. All right. And you'll see that they're all the zip codes. Yes, save it. All right. Before I do that, let's go ahead and grab all this and put it in the notes and get rid of it. All right. Java. There we go. Don't want to lose it, but I don't want it taking up valuable code space and output space here. All right. So there are all my zip codes, as we see down here. What I want to do is I want to have a report. We want to report how many times each zip code appears. All right. Okay. So one brute force way of doing this would be to, for each zip code, each possible zip code, iterate through the list and count them up. No big deal when I've got, what, 4 unique zip codes here and only maybe like a dozen records or whatever I put down there. But what if you had a file with, say, 100 million records, right? Now, like 100 million records and at least, 100,000 zip codes are possible here, or 10,000 zip codes. No, 100,000 zip codes are possible, all the way up to 99999. Add in the extended zip codes of 4, right? And now you're talking about millions of possible zip codes. Millions of possible zip codes, right? Times millions of possible records, right? And millions times millions is what? Trillions, right? Tens of millions times tens of millions is now quadrillions almost, right? No, I don't want that brute force approach, right? So how could I use a map to help me solve this problem really, really simply? Right? What do I want to actually report? I want to report the number of times each zip code appears. In other words, I want to report 1, 2, 3, 4, 5 appears once. I want 68116. I want that to report that it appears 5 times. Right? What does that look like to you? A map. Right? It maps strings, which are zip codes, to integers, which are the count of the number of times it appears. Right? That's cool, because now we only have to go through the entire list once. Let me outline it for you. Right? But first we need this zip counts, or whatever you want to call it. Hash map. Excuse me. Okay? Here's my outline. For each zip code in zip codes, right? Ask the map, or retrieve the count in zip counts, right? 1, if this is the first time we've seen zip code, seen the zip code, right? Then what should I do? What will the counter be? It'll be maybe 0 or something like that. We'll discuss the details when we translate this pseudocode. But otherwise, this is the first time we see it. So we'll set the count to 1 because it's the first time. Right? Otherwise, 2. If this is the second or second, third, etc. time we've seen it, then what should I do to that count? Increase it by 1. And we know how to do that plus plus. Okay? There's my outline. If you were to do this from a design perspective, you'd write this up on a whiteboard. Outline your steps. I've outlined it in my code here because I don't have a whiteboard immediately available to show you, right? But you could do something like this in code to outline it. This is pseudocode, this is fake code, but otherwise I would outline each one of these steps. And by the way, if this were Python, I would write a one-line map comprehension, right? And then get it all done just in one line, right? All right, so for each zip code, how do I translate that part? For string zip in the collection zip codes, right there. Okay. Once you've translated that, you can go ahead and get rid of that. Okay, because leaving this stuff is not good. And leaving this stuff is, I'm going to leave this stuff for the notes so that you have the benefit of reading it again if you need to. But this kind of stuff should not appear in your final code. It's cruft. It's garbage. Get rid of it. Right? It was just notes to yourself as you developed it. Once it's developed, that's it. Get rid of it. Okay. Retrieve the count in the zip counts. How do I do that? Zip counts. Remember that I've got my key here, which is a zip code. .get zip. Right? That's going to return what? An integer, a big I integer. Count. There. Now, get rid of that line now. I've got an if-else-if statement here. If this is the first time we've seen it, this is the first time we've seen zip, right? Then I'll do one thing. Otherwise, I'll do another thing. Okay? So I can't write that code. That would be awesome if I could write this in plain old English, right? Is this the first time we've seen it or not? Count. What value will counter be if this is the first time I've seen the zip code? It could be 0, but did we ever actually put anything into this map? No. We've already seen what happens if you ask for something that doesn't exist. What does it give it back to you? Null. So if the count is null, and by the way, that's why we have to use big I integer, because little I integer cannot be null. Int x is equal to null. It doesn't allow you to do that. Primitive types, the lowercase I int, the lowercase d double, the lowercase c char, those have to have a value. You cannot assign it a null value. Only big I integer can be null. Okay, big D double can be null. All right, this is the first time we've seen it. So my count should be 1. Let's reset count to be 1. Right? And then let's put it back into the map. Zip counts dot put. Zip code is going to now map to count. Okay? There, we've taken care of that. Otherwise, this is the second or third or fourth or fifth time we've seen it. Right? That's the else statement here. So count will have a value now. It'll be 1, or it'll be 2, or it'll be 3, or it'll be 4. We just simply need to go count plus plus and put it back into the map. Okay? Another improvement that I can make. Is there any difference between line 34 and 37? Nope. Should I repeat the same line of code in the if and in the else statement? Nope. Let's go ahead and take that out because it is executed unconditionally. Right? That's much cleaner code there. Right? Remember the DRY principle. Don't repeat yourself. Right? Fewer lines of code is better because it's fewer to read, it's fewer to understand. Let's see if this actually works though. System.out.println. There we go. All right. 902.210 appeared once. That's 68503. It appears 4 times. 68116 appears 5 times. Right? There. I solved that problem in only a few lines of code here. No clever code here at all. Right? All I was doing was asking, well, you've seen it so far? Yes. Okay. What was the count? Right? 5. Okay. Now go ahead and make your count 6. Right? I was just asking this smart data structure to do all the heavy lifting for me. Awesome. Right? Because now it is way simpler code here. If I had done that the brute force way, first of all, it would have been extremely inefficient, but also it would have been, I would have had to write really clever code. How do I know that this is the first time I've seen this zip code or not, right? I'd have to look back. Oh, I saw it up there. Or I would have to sort it somehow to make sure that all of the zip codes were contiguous, all right? And I didn't have that problem. There would be a whole bunch of other things that I would have to solve, basically, in order to solve that problem. But a map does 90% of the heavy lifting for me, right? So here's that exercise. Exercise, zip codes. Right. Oops. Java, there we go. All right, did you do something like that in 155A? Like zip code uniqueness and stuff, counts? And I thought that they did that exercise, all right? Anyway, awesome maps. Okay. The only other thing I wanted to do today was quickly introduce you to strings because we've been implicitly using them up to this point, right? All right. I don't know why it's not code highlighting that, but whatever. We're good. Java has a string built-in type that we've been using up to this point. For those coming from a C background, no memory management, no null terminating character, basic concatenation with the plus. Those coming from a Python background, don't worry about any of that. A string is basically the same thing in Python and in Java. In fact, they are both immutable. Once created, the contents of a string cannot be changed. Let me show you. String, my name, Chris. Oops, I misspelled it. I didn't capitalize C. Right? So let's go. Name dot to upper. There we go. I want to convert it to an uppercase character there. I want all uppercase, CHRIS. System.out.println, name. Does it work? No, it did not. I called that function though, but that's because strings are immutable. This will be something that is new from those coming from C, right? It's like putting a const in front of everything, right? And it is a very good thing, right? Because you have thread safety out of this automatically. The problem was this actually does convert it up to CHRIS, all uppercase, but the way that it does it is by returning a new string, right? I don't know, foo is equal to that. The old string is still the same, all lowercase CHRIS, but the new string foo is all now uppercase. You have to capture that new string. It creates a brand new string with contents changed, and then it gives it back to you. You have to capture that value, right? The original is completely unchanged because it is immutable. It's unchangeable. Once created, the contents of a string cannot be changed. You have to call functions, and then it creates new strings for you. What other functions are there? To lowercase, right? That's nice. Dot character at, that gives you the character at a particular index, and it is 0 indexed, right? What else is there? Right? Dot contains, right? My favorite is going to be dot substring here. So let's start it at 3. What's that going to give me? String bar is equal to. What is a substring? It's a part of a string starting at index 3. 0, 1, 2, 3. So it'll give me what? IS. There we go. You can also have a substring of a particular size. Let's go bar baz. There we go. And I'll start it at index, I don't know, 2, or let's go with 1, and go up to index 3. Right? And that'll be baz. It starts at index 1, which is going to be H. And then it goes up to, but does not include index 3. Right? It's always going to be one less. It's always inclusive, exclusive. Wow, these are some fine functions in the string library here. Right? What else might there be? Java string. Right? For that answer, you have to RTM. Remember what RTM stood for? Read the manual, or read the freaking manual, right? Pretty much anything that you would want to do with a string, there's probably some way to do it in here already, because, wow, there are dozens and dozens and dozens of functions here. Compare to, that's how you compare one string to another string. What else is there? There's the or starts with. That might be useful. Ends with. Is there such a thing? Yes, there's ends with, right? Equals, ignores case. You can actually get the byte content of the strings. Index of the first character, right? In other words, if you're coming from a Python background, pretty much anything that you could do with strings in the string library in Python, there's an equal function here to do it. Those coming from a C background are going to really appreciate this, because there are a lot, like 100 more functions that you can actually use. And any exercise that we did in C, there's probably a function to do it. Right? In fact, in the C/Java section that I do in the fall, I repeat the C exercises that we do in C in Java, but give you a clue, like that there's probably a function already there to do it for you, right? And all of these solutions end up being one-liners, one call or two calls to a string library function like this. You can get the length of the string, et cetera, et cetera. But again, those coming from a C background, remember, there is no such thing as the null terminating character. There is no memory management, and you can do basic concatenation just using the plus, right? All right. We'll go ahead and pick it up there on Friday then, with probably file I/O by that point.